Hi, this is Calandra. In this video, we will look at factoring polynomials, specifically identifying the greatest common factor and factoring by grouping. So the first step when factoring polynomials is to factor out the greatest common factor, if there is one. The greatest common factor is the largest quantity that can be divided into each of our terms evenly. So let's apply this to our first example, where we want to factor completely. To identify your greatest common factor, start with your numbers. So in my two terms, I see that I have a 2 and an 8. So the greatest common factor would be 2. That's the biggest number that can divide into both of these evenly. Next, I need to examine the variables they have in common. So I see both of my terms have an x. Well, how many x's do they actually have in common? Well, here I have 5 x's being multiplied together, because x to the 5th just means x times x times x 5 times. And here I have 2 x's being multiplied together. So the greatest common factor in that case would be x squared. That's the largest number that they both have in common. So that's what I want to factor out. So if we start with 2x squared, in parentheses we need to write what we have left. Well, in the first term, we've already factored out the 2, so we don't have a coefficient. If we factored out an x squared, how many do we still have left? Well, we have 3. You can always think of this as the reverse of the distributive property. When you multiply it back out, it should take us to where we started. So I know x squared times x cubed gives me x to the 5th. Okay, next, if I factored out a 2, that means that I'm left with a 4. I factored out x squared, so I don't have x squared anymore, but I still have a y to the 4th. We haven't done anything with that. And this would be my factored expression. Okay, let's look at example B. Okay, to factor this completely, again, we're looking for the greatest common factor. So if we start with our numbers, well, first let me make sure that you see that we have 2 terms. They just look a little bit different because one of our terms is in parentheses in this case. Okay, so with our greatest common factor, we see our 2 terms do not have any numbers in common. They don't have any single variables in common because in our first term we have an x. The second term we don't have a loose x. All we have is what's in parentheses. However, notice both of them have the same quantity in parentheses. So x plus 3 is the greatest common factor. So that means that we can factor that out, x plus 3. And now in parentheses, we're going to write what we have that's left. So remember, you can think about it as the reverse of the distributive property. What do we need to multiply x plus 3 by to take us back to 4x times x plus 3? Well, that answers 4x. Well, what do I need to multiply x plus 3 by that will give me a negative 5 times x plus 3? Well, since we got rid of the x plus 3, we still need to multiply by negative 5. So that would be our answer. Okay, well, next we want to look at a method called factoring by grouping. And there are 3 basic steps that you're going to follow. First, you want to group the first 2 terms together and the second 2 terms together. Secondly, factor out the greatest common factor from each of the 2 groups. Third, factor out the greatest common factor from the entire expression. So doing it will make a lot more sense than talking through it in words. So let's start with our first example. So to factor by grouping, I'm going to group my first 2 terms together and my last 2 terms. In my first 2 terms, the greatest common factor is a. So I'm going to factor that out. And what do we have left? It looks like we'll have a b plus 5 left in parentheses. In my second two terms, 3b and 15, I can factor a 3 out. In parentheses, we write what we have left. So in my first part, I have a b left, and from the 15, it now becomes a 5. So notice now we have two terms resulting. And our two terms both have a b plus 5 in common. So b plus 5 is now our greatest common factor. And if we factor that out and we write what's left in our second set of parentheses, we see we're left with an a plus 3. An a from the first term and plus 3 from the second term. And that would be our answer. In part B, again, we want to factor by grouping. We'll know that we're going to be using factoring by grouping if you have 4 terms. Okay, I'm going to group my first 2 terms together and my last 2 terms together. In my first 2 terms, I can factor out an x squared. So from x cubed, I have an x left. From 9x squared, I have a 9. In my next 2 terms, I can factor an 8 out, and what I have left would be an x, and then 8 can go into 72 9 times, so I have a x plus 9 left as well. So now in these 2 resulting terms, notice they both have an x plus 9 in common, so we can factor out an x plus 9. And in our second set of parentheses, again, we write what's left. And in our first term, since we've taken out the x squared plus 9, we're left with an x squared. Bring down our sign, plus, and we're left with 8 in our second term. So that would be our answer. Okay, going on to our last example. Okay, still same process. We group our first 2 terms and our last 2 terms. In our first 2 terms, we can factor out an x squared. So from x cubed, we're left with an x, and then we have a minus 1 left, because if you factor out all of x squared divided by x squared leaves you with 1, so minus 1. Okay, in our next 2 terms, notice we have a subtraction, which we haven't had before. You're always going to subtract or factor out the negative of whatever the greatest common factor is. So in this case, we can factor a 5 out of both. So we're going to factor a negative 5 out of both. So think of this as the reverse of the distributive property. What do you have to multiply negative 5 by to take us back to the negative 5x we started with? And that would be an x. Well, what do I need to multiply this negative 5 by to give me the positive 5 I started with? And that will be a negative 1. So now we have our 2 terms with a greatest common factor of x minus 1. And now what's left? In our first set of parentheses, since the x minus 1 goes away, we factored it out, we're just left with an x squared. In my second term, since we factored out that x minus 1, we're left with a minus 5. And that would be our factored expression.